Okay, so here's a video of me explaining the principles of the question posed here, and I'm just going to talk you through the solution that we have drawn up here on AutoCAD. So, as you can see, figure 14.64 shows a pictorial view of a shell structure. The surface of the structure is generated by translating the parabola ABC in a vertical position along the parabola BE, whose vertex is at E. Draw the plan and elevation of the structure. So, as you can see here, this is our structure. We have the points A, B, C, D, E, and F. We have our measurements here, A to C, C to F, and then the height then from F to E. I'm going to talk you through now the principles of this solution. So what we have to do first is draw the parabola A, B, and C. So that's what we have here, A, B, and C. So to construct the parabola, what we do is we draw our 5 divisions here of this line. So this line here is divided up into 5, and we draw them straight up, as you can see here. And then we divide this line here, then into 5 parts, and we join these parts back to B. And where these intersect, we'll call this 1, we'll call this 1, where 1 comes up, where 1 intersects here, that's 1 point. And then we repeat that then where 2 intersects 2, that's another point. And the overall size of this is found, as you can see by the question, because it's 24 meters by 24 meters, but it has to be in the correct scale of 1 to 200. So once we do this, we can create our curve then A to B, and then we repeat this process then on the other side to get B to C, and this gives us our parabola ABC. So what we have to do next then is project our points B, E, CA, and FD across. Okay, so there's B, that's where CA will be, that's where FD will be, and that's where E will be. Okay, so what we're able to draw in is this line here, and this line here, because they're all given in the question, as you can see here. Okay, now feel free at any point now, if there's any things you want to go back on, pause it, go back over, replay it to ensure you're fully understanding this solution as we're going along. So now what we have to create is we have to construct a parabola BE, which is going to be from here, BE, ensuring that the vertex is here at E. Okay, so once again, we traditionally go with the 5 divisions. We divide here into 5, as you can see, and then draw our projector lines up. 1, 2, 3, 4, 5. We then divide our lines from here to here into 5. 1, 2, 3, 4, 5. We project these divisions back here to E. And then where they intersect once again is where you find your curve. So we'll call this 1. We'll call this 1. And where they intersect then will give you your point. And this is done for 2, 2, 3, 3, 4, 4, and 5, 5. Okay? So next then we project our points down to plan, where what we are able to do is find A, C. Now the question is, can we find D and F already? No, we can't. So what we have to do is we take our height here, as you can see, from E to FD, E to FD, so that distance there. We bring that back over here to our parabola. We draw it down from B, and wherever that intersects the parabola at 2 points will give us our width. Okay? So what you can do is put your compass 1 point here and 1 point here, and put that then here, and then mark off your 2 sides. Now, the curves, as you can see here, A to D, and C to F, which is there C to F and A to D, those curves are hyperbolas. Okay, so how we construct them is we divide, once again, this side here into 5 parts, and then we divide this line here into 5 parts, as you can see here. But the divisions don't go straight across, they go to point D, as you can see here. And then these divisions come across to point F, as you can see here. And then to find our points on this, then what we have to do is, I'll just let you see this now and just understand that they're not going straight across. They're going to D, and then these points are coming to F. So then we'll call this point 1, we'll call this line here 1, we'll call that line there 1, and where they intersect then we'll call that point there 1, we'll call this line here 1, and then where they intersect is where you find your point. And then this is repeated then 2, 2, 3, 3, 4, 4, and 5, 5. Okay, so then that gets you your curve A to D, as you can see, okay? And then that process is just repeated down here from C to F, but I won't draw in that construction just because it might be a bit difficult to understand. So that is the main principles of this question and the solution, and feel free to go back over it and look at any and compare it to questions that you are doing, and use it as a resource to help you.